Readability is vital to the effectiveness of automated tests. Tests that read and communicate well provide an invaluable tool to comprehend, maintain, and extend software systems. Today we're going to talk about a common test smell that exists that makes tests difficult to read. We're going to talk about a couple of causes of this smell and how to fix them. The examples are going to be in Ruby and RSpec, but apply to other languages and frameworks as well, particularly those in the dynamic language realm. The testing smell that we're going to talk about today is obscure test. Obscure test is a test that is difficult to understand at a glance. Notice the emphasis on glance. If I can't gain a general understanding of what logic is being verified by glancing at a test, chances are that I have a case of obscure test and should do something to improve the readability. Obscure test has many causes, however, I find two to be particularly prevalent. Those two are mystery guessed and irrelevant information. Mystery guessed is data that has an ambiguous connection between setup and verification logic. Generally speaking, this occurs because test data is set up outside of a test and then used within the test, creating an unclear connection between the origin of the data and how it affects the result of the test. Irrelevant information is simply information that is not relevant to the test. Usually this kind of information exists to satisfy the constructor methods of dependencies. Irrelevant information distracts the reader by creating noise and making it difficult to distinguish between what information is relevant to the test and affects the outcome of the test, and what information is not relevant to the test and does not affect the outcome of the test. A pattern that I found incredibly helpful in correcting both of these issues is creation method. Creation method is a method that constructs ready-to-use objects. Again, there are a few variations of creation method. In practice, I find that my creation methods usually exist as a combination of parameterized and anonymous creation methods, where I provide default values that I can override as necessary. To demonstrate this point, we're going to look at an app called the Floridian Christmas Activity Planner, because Floridians are a festive bunch, but Christmas in Florida is a little bit different, mainly because of the heat. So we have to get creative with our Christmas activities to get into the Christmas spirit. We have a class called Christmas Activity Planner that accepts three keyword arguments: participants, precipitation, and temperature. Using these arguments, it then makes a recommendation based on the value of the arguments, such as whether or not it's rainy and the number of participants that we have, and whether or not it's cold outside, which for Florida is really anything under 70 degrees. Notice also that our precipitation object that we're passing responds to a fetch message that is just fetching some precipitation data from an API defined elsewhere. First, we're going to look at a traditional approach to testing this using RSpec constructs. We have a couple of contexts here of when it's rainy and when one person is participating in the activity that it recommends watching a Christmas movie, in this case Home Alone. To figure out what's going on with the test, we start by looking at subject. Knowing that subject is an RSpec construct probably defined elsewhere in the test, we scroll up to find that it is defined on line 6 and is just an instantiation of our described class. Our described class is accepting a few different variables that we're defining in lets in different parts of the test. For our precipitation objects, we're just defining a double that responds to two messages, a query message called rainy and a command message that fetches the precipitation data from the API. Knowing what subject now does, we see that it's being sent the recommend message and that we're expecting it to return a string recommending a Christmas movie. We have a general idea of what's going on with the test, but we have to look outside of the test to gain an understanding of what's going on. We further have to figure out which lets are relevant to the test and which lets are not. In this case, we have a scenario where we have a mystery guest in our test because it's not clear to see what data is set up to achieve our desired outcome in this test. We see that we're defining participants in our first context and then a value of rainy, which is used to customize the return value of our precipitation object when it is sent its query message. But we also see that we have another let variable called temperature defined at the top level that applies to all of our tests, called temperature, that has a default of 85 degrees set, a very typical temperature for Christmas in Florida. Because we have this let that is effectively acting as a global variable, we can't tell if it affects this test, and we can't tell if it affects other tests. So we have this case of mystery guess where it's difficult to discern what data is being set up that actually affects the result of this test. Contrasting this to our spec where we're using our creation method pattern, we again have our context of when it's rainy and only one person is participating in the activity that it recommends watching a Christmas movie. Looking at this spec, however, we'll immediately see a difference in that we're defining the data that we need for the test directly within the test. We're making use of two creation methods called stub precipitation and build planner to set up the necessary data to arrive at the conclusion that we're expecting in our assertion. Stub precipitation accepts a keyword argument of rainy, that is a Boolean value, and build planner accepts three keyword arguments: temperature, participants, and precipitation. In this case, we only care about two of them, and so we only specify two, as our build planner creation method has defaults defined for each of the values that we can rely on if we don't care about them. One thing to notice about this test is that it has gotten rid of mystery guest, but it has also created a sort of high-level approach to how we're setting up our data that allows us to pretty quickly see what is going on with the test and what logic is being verified, therefore getting rid of obscure tests. Looking at these creation methods, if there's something that we feel might be interesting happening inside of these, we're free to dig into these and see what logic actually exists in there. So in the case of stub precipitation, we decide that we want to see what is actually going on with stub precipitation. It's very easy to see where it's being used since it's using a normal method call chain and not RSpec constructs that are evaluated at different scopes depending on what context you're in. It's very clear that the value is being assigned to the result, as we see in a lot of other code. Digging into stub precipitation, we see that it again has a keyword argument of rainy with a default value of true. This is really nice, and a thing in dynamic languages that makes this style really nice is that we're able to define defaults so that if we don't care about whether or not it's rainy, but we need this value set up for some reason, we don't have to specify the rainy value. We can just rely on the default and it will set up an object for us. This is an instance of an anonymous creation method. In this case, however, we do care about the value, and so we're using an instance of parameterized creation method. It's just a double that responds to the rainy message again with the customizable value in the rainy variable and the fetch message just set to a return value of nil. Scrolling back up to our test, we also see that we have build planner, which is again a creation method. And as a side note, I'll usually prefix creation methods that are creating collaborator objects or dependencies. I'll usually prefix those with stub and then the name of the object, whereas I'll prefix the system under test, or the class that we're currently testing, with build and then whatever the name of the class is. In this case, build planner. It's just a convention that I follow, and then I also will define the class that is constructing the object that we're testing at the top of the file, just to make it easy to see what's going on right away. Looking at our build planner class, we again see that it accepts 3 keyword arguments that mirror the source, and that it provides defaults. Stub precipitation is the default for precipitation. So this is just our creation method that we're using for our precipitation object. We have default participants set to 2, and default temperature, again, set to 85. And then we just instantiate the class. This allows us to do what we did in our first spec here of specifying the data that is relevant to our test in a very succinct way that allows our readers to make a clear connection between the setup and the verification. Moving on to the next example, we're going to look at a case of irrelevant information. In our spec, our context for when it's not rainy and when it's cold outside, our activity planner recommends a bonfire for us. Lets us know that it's freezing outside, tells us how cold it is, and tells us to go grab some hot chocolate and have a bonfire. Again, looking at this test, we have to go digging outside to figure out what values are actually affecting this test. In a smaller test file like this, it's rather trivial for us to scroll up and see where different lets are defined. In practice, however, test files are usually not this small, and usually a lot more values are defined than this, making it a much more difficult process to actually hunt down this data. For the purposes of demonstration, though, we've kept this test file relatively simple. So we're defining our temperature as 69, which is cold for Florida, and we're also defining 2 other lets in the upper level context here for whether or not it's rainy and how many participants are in this activity. Now, in reality, we actually don't care about how many participants are in this activity. If we look at our source code, we see that if it's rainy, then we care about the number of participants. But if it's not, then we're just looking at the temperature. However, because of the way that we have set things up with our spec, we have to define this participant's value to satisfy our constructor method for our described class. If we do not satisfy this, we'll get an error telling us that we have an undefined method or variable called participants. It would be nice to not have to define this value since it distracts from the information that is actually important, which is rainy and temperature. If we look at our creation method, we again have a nice answer for this. We set up our precipitation object, this time with a rainy false value. We also set up our temperature and build our planner class. Notice that we do not need to specify the number of participants in this test because we again have a default of 2 set up in our creation method that will satisfy the constructor method if we choose not to pass a value. This allows us to avoid irrelevant information and keep our test concise and pointing the reader at what information is actually going in to make this result happen. Looking at a final example here, we're going to see a case of both mystery guessed and again irrelevant information. Looking at the context for when it's not rainy and the temperature is normal, we have a recommendation to go to the beach and make sand angels and Sandman. It also tells us the temperature. Again, looking at this test, we can see that we're going to have to do a little bit of digging to figure out what values are actually going into making this result happen. We look up and we again see our rainy and our participants. Rainy is relevant to the test, but again, participants is not. So we have a case of irrelevant information in participants that exists to satisfy the constructor method that we've defined in our subject up at the top of the test file. We also have a very bad case of mystery guessed here in that we are using a temperature variable in our assertion to let the user know how hot it is. And this value is not defined anywhere near the test and requires us, even in a small test file, to do a fair amount of scrolling up before we actually realize that it is the value that is being defined on line 13, the temperature that is being defined on line 13. Having this value so far away from our assertion logic makes it difficult for our readers to connect where the setup data is to start with, and also how the setup data affects the test. We have to constantly scroll back and forth just to reason about the test, and this takes away time and it takes cognitive energy to figure out what is going on in the test rather than to figure out what the test is doing. Finally, once again contrasting this with our creation method example, we stub our precipitation again, and this time explicitly set a temperature value of 85 in our test that we then pass in to our creation method to instantiate our planner object. In the exercise and verification, we can then use that temperature object that we initialized earlier in the test in our assertion, and we have a clear connection for our readers between the setup and between the verification logic in our test, allowing our readers to focus on the functionality that the test is testing rather than on figuring out the logic in the test. One hesitation that I had when I was initially considering adopting the pattern of using creation method in my specs versus constructs that our spec provides is, wait, what about all of that duplicate code that I'm going to be writing in variable declarations? Shouldn't I dry that up with our specs constructs? I found that our specs constructs decrease readability in tests, and that the amount of extra code that you're writing is actually rather trivial. If we look at our traditional RSpec approach, we see that the test weighs in at 58 lines. If we look at our creation method pattern approach, we see that our test file weighs in at just a few lines more at 63 lines. For a few more lines, we've gained a significant amount of readability, and is a very nice bonus, gained the ability to maintain our test much more easily since we're not relying on global data like we have in our traditional approach, in our traditional spec. Which leads me to a principle that I have worked hard to follow since I came across. And the principle is that communication is more important than being dry. Making your tests communicate and making your test readable to readers is more important than drawing up a little bit of code. I found that the benefit of communication far outweighs the cost of a little bit of extra code. One pitfall to be aware of with this pattern is not to get too clever with the logic in your creation method. You really should avoid conditionals and things of that nature, as it makes your creation methods difficult to reason about, which again obscures the readability of your tests, which is our goal in the first place. For further learning, I highly recommend xUnit Test Patterns, Refactoring Test Code by Gerard, Meszaros. It covers all of the concepts that we went over today, as well as a number of additional concepts that are incredibly helpful in maintaining a good test suite. Testing Rails by Josh Steiner takes a lot of these concepts and puts them into Ruby and Rails land, and demonstrates a lot of them in a very practical way that is easy to start applying to your tests quickly. Thoughtbot's blog also has a wealth of testing information for more bite-sized learning. And finally, trying this out for yourself is the best way to weigh the pros and cons and see if this style works for you. With our newfound testing knowledge, we have been able to create a Christmas activity planner that is well tested and makes Christmas a little more jolly for Floridians everywhere. Merry Christmas!